Record in the cloud. Awesome. Well, thanks everyone for coming. This is going to be a kind of a joint event between the Trino community and the Superset community. I'm Srini. I'm a developer advocate at Preset and really involved in the Superset project. We have Brian here, who's a data engineer and developer advocate from Starburst. You'll see him around the Trino community. So today we're going to talk about kind of an interesting use case of Trino and Superset. Kind of working with MongoDB and Pinot, which are two interesting databases that you don't always see in the same conversation. So should be a fun talk and a fun demo. And I'll let Brian take it from here.
Cool. Thanks, Srini. And thanks for everyone for having me here. So yeah, I'm Brian Olsen, developer advocate over at Starburst. I'm also a Trino contributor in my spare time. And you can find me on the Twitters on Bits on Data Dev. So today I just want to kind of get a quick, not show of hands, but if you can go into the chat and say if you're first, let's go with, does anybody actually use Trino? Give it a second to see if anybody uses Trino. I'm getting crickets. No, I'm getting I got a yes. I do. Okay. We got two out of about 23 attendees that are using it. That's good. Okay. We just started. Oh, cool. Very cool. Nope. Out of the nose, or anybody else have you at least like heard of Trino before or heard of Presto? As I think another bit of the people that have never heard of Presto, if you're using Presto, you might actually be using Trino. You just don't know it yet. Heard of it, don't know about it. Cool. Okay. Well, I think that's a good bit of understanding of kind of where the audience is. Heard Presto. Okay. Yeah. So this will be, I think, a good enlightening thing for those of you who have heard about the Presto query engine and kind of give a frame of reference for where we're at. So basically the talk today is going to be starting out, for those of you that are kind of listening to this in the background, first slide, I'm just going to basically cover the meat and potatoes of what Trino is. So if it's a kind of a too long didn't listen kind of thing, you can just kind of tune out for the backstory, or if you're already super aware of what Trino is and know everything about it, then you can tune out till we get to the fun little demo part. But I do highly recommend the backstory is pretty interesting as well. So we'll do the first bit there, do a little bit of backstory, kind of talk about like the analytics space in general, and kind of what conditions led up to the culmination of Presto, and then kind of some of the open source splits that occurred within the community, and now what's brought us to Trino today. Then we're going to cover an interesting little scenario that we just dreamed up with some airline flight data that's sitting inside of a Mongo database, and and COVID data that's sitting inside of Pinot, and we'll visualize it up on Superset for you. So the Trino TLDL, basically in a nutshell, this sentence sums it all up. It's a fast distributed SQL query engine. So, it's we want to make sure it's interactive as opposed to kind of predecessors that were relatively slow before. We use SQL. We actually use the standard ANSI SQL, not like some data stores that kind of roll their own version of SQL or kind of cut some corners here and there. Like we're very strict on trying to focus on adhering to standards in this project. It's a query engine, so it's not like a lot of data. A lot of times Trino is called the database. So we always like to kind of clarify that it's not a database. Actually, it's just a query engine, but it sits on top of multiple databases and kind of interacts with them. So we have essentially this, clients that will come in, so we can have anything that speaks in JDBC, in kind of Python client, anything that has a client that's either supported or formally or informally by the Trino. Some clients can actually be informally kind of promoted or supported. I think there's a Node client, for instance, that is supported by the community, not officially by the Trino project or the Trino maintainers themselves. However, if you have a client that works, it basically can interact with our coordinator. We have basically a distinction of two nodes, a coordinator node and then worker nodes. Here we kind of have this zoomed in version of the coordinator. It does a lot of the initial planning and basically dissecting of the SQL query that's coming in. And once it basically schedules, it utilizes a couple of these APIs that we use, and we'll talk about where these APIs live. They live in this thing called an SPI, and we'll see that later. And they basically use that information. It's basically like metadata to kind of reason about how we should be planning these queries. And so we'll be able to talk the language of all these different data stores like Mongo, Pinot, Postgres, Kafka, and basically pull stream data in on individual workers in parallel, and also taking advantage of parallelizations if it's available in the data store that we're pulling from as well. So for instance, Elasticsearch supports reads in parallel over their different distributed system, so we can quickly and easily take advantage of streaming over doing basically a stream search, or can't remember exactly what it's called now. I'm like blanking on it, but yeah, basically it's like a page search that goes over their different distributed workers as well. And again, theirs is called like I don't know, individual worker nodes. So we pull these data in from the data source. This ultimately gets processed, and what's really interesting is that you can join data over different data sets. And so this is typically like something that you're not able to do in stores like MongoDB, because they were designed to be a NoSQL document store that you essentially try to denormalize your data and make it to where all the data is just pre-joined and representing how it's going to be inside the application. And then you push that data in a document format, and that's the same way you push it in is the same way you get it out. And you don't really, the idea is you're trying to avoid doing joins. But as we know, Mongo is maybe not the only data store that's sitting in your enterprise. You're going to be needing to do some sort of joins across with other data stores, especially maybe there's a certain project that comes up where you have to collaborate with other teams that store inside Hive, or doing more big data analytics type stuff. And so now you need to merge that data. And so this is why where Trino kind of comes in, is it's trying to basically solve for that problem of how do I merge these data sets, these distinct silos of data and all these different data sources, and pull them together with basically no pre-moving of the data, essentially, and no ETL. And for those that aren't familiar with ETL, it's extract, transact, load, and it's a very common pattern that we'll see that came up in OLAP. So let's move on. So that's the basic overview of kind of where Trino, what Trino does. I want to take a step back and kind of what conditions came about to require such a system like this. So first, I like these maps. These maps are in a book that, if you're not aware, is called Designing Data Intensive Applications. It's by author Martin Kleppman, and he has these cool little maps in the beginning of each of his chapters that kind of talk about like the kind of area that he's about to explore in all of kind of databases and data stores in general. And so in this one in particular, he's talking about distributed storage and retrieval, but he's also kind of splitting it up into, he calls it the Kingdom of Analytics and the Republic of Transactional Processing. And so the formal names for these kind of two areas on this map, and of course we're living over here in the Kingdom of Analytics. The formal name is or kind of terminology used for it is called OLTP versus OLAP. So OLAP is more of that Kingdom of Analytics, and OLTP is more of the Republic of Transaction Processing. So OLTP is kind of traditionally, these focused on data integrity. You're trying to kind of make sure that you're being able to do transactionally, keeping the data as expected in a good state for every single insert, update and delete that you do in that database, and that anybody that is reading from that database has a correct view of the data at any particular point. And if something fails, it will, kind of fall back. So data integrity is really kind of central to OLTP. And this is kind of your standard relational databases usually typically are more on the side where they're, focused on giving you that transactional integrity. OLAP, on the other hand, is basically saying, okay, forget all of these updates and these reads and these massive amounts of inserts and deletes going on. Like, we're just going to basically move the data into one location. We're trying to pull from all these different locations, and we want to just analyze the data and really focus on making those reads happen really fast. So that's really what OLAP is focused on. And then there's kind of, a whole newer class, which is kind of like NoSQL and various other databases. It kind of gets fuzzy on the categorizing, but, roughly a lot of NoSQL databases fall outside of OLTP and OLAP and have various other needs that they're trying to focus on. But we're going to really be focusing on this middle one, this OLAP one, and how things progressed for us to get to Presto and now Trino. So back in the 80s, there was this concept that was brought up called data warehousing. And so this was kind of the initial earliest days of developments of OLAP. And so for frame of reference, this is around the time that we were all kind of listening to CDs and Walkmans, and maybe some of you remember the Eiffel 65 song Blue Dabba Dee. And probably the only database work that any of us were really doing at the time was filling up our encyclopedia of Pokemon for Professor Oak. So sorry if anybody doesn't play Pokemon or doesn't like Pokemon, but had to throw that in there. So basically, data warehousing is the idea is you're trying to take these distinct data sets, similar to what we were talking about with Trino, and you're trying to get them into one single data store. And the thing is that while you're pulling that data in, you're basically trying to read it in one time and then basically make this giant copy of all your data across all of your business org, so that in one location you can actually do a join on the data just like you would in any individual data store, but now you have it all in one place. So this was great. I mean, this got data in one location, and ad hoc queries could now be run across like a wide variety of data across your business. But this was like ridiculously slow. This is still like, even to this day, a problem of having these slow ETL and really fragile ETL pipeline processes that are, either failing or sometimes just taking really super long, and nobody's able to actually run analytics on this. Now, in the early days, 80s and 90s, it wasn't, so bad, but it's because we really weren't dealing with a huge amount of data. But as time progressed, we ran into kind of this thing that was kind of called Web 2.0. And so we didn't really solve the problem of it being slow, and then we got more data. So how is this actually addressed? Well, we brought on this thing called Hadoop, and instead of basically taking these vertically scaled warehousing days of old, we decided, okay, well, in order to actually scale up to the amount of data that we're getting from Web 2.0 from social media, now everybody's got a phone and everybody's recording everything and just uploading every video of cats and just like crashing things all the time. So it's an issue, right? And the more you vertically scale, eventually you're going to run out of thread to scale up, and it's just, the server room's going to be too hot. If you're one server that's handling all of these transactions and all of this queries goes down, then you're pretty much out of luck, and you just have to, hopefully have another giant scaled cluster that you can run on. So, to address that initial problem, they didn't actually end up solving anything that of the slowness of warehousing. But what they did is they basically made it possible to ingest all of the data that was coming in from this Web 2.0 revolution. And I call this, in tongue in cheek, warehousing 2.0. So it's basically the same problems, just handling at least the new amount of volume of data that was coming in. So, what really ended up happening is the issue here is now we didn't have SQL to actually do this. We were just able to basically ingest the data, dump it into HDFS, and nobody could literally do anything with it because the only way you could actually access this data is, you had to have a Java programmer that could write MapReduce. And I think eventually Python came into the mix. So if you were a Java or a Python programmer, you were doing really well in the early days of Hadoop, because companies were just struggling really hard to get people who could write this to this paradigm. So, to resolve this, developers at Facebook created this other technology you may be aware of called Hive. And it was kind of the initial SQL on Hadoop solution that would take in SQL and then generate a lot of these MapReduce operations for you. And so, again, this is great. This actually simplified the development process. People are actually able to run SQL queries again. But we were back to basically where we started with warehousing, which is that it's ridiculously slow, and it was only, as data was growing, only getting slower and slower to actually run these. So the issue was, for the design of all of these systems, really human in the loop was just not a consideration at all. And anytime you had a data scientist that was sitting there, I don't know if anybody here is a data scientist that has actually used Hive, but it's ridiculously slow. You're constantly waiting for a resource to open up, and the anecdote from Facebook scientists around the time that the Presto was created around 2012 was that on a good day, they could actually run 6 queries on Hive. So, we're still sitting here with this really slow data being out of date, data is duplicated and expensive, and you're constantly just having to move data around via ETL. And then once it's there, it's just ridiculously hard to actually get any data out. So Presto came in to the picture around 2012. Martin Traverso, Dane Sundstrom, and David Phillips were the co-founders of Presto, all working at Facebook. And they were basically aiming to solve Facebook's latency issues with basically analyzing a lot of data over this giant, I think 300 petabyte MySQL farm. And so they came in at a really interesting time. They all had previous work together, and they had actually worked on databases as well in previous companies. So they already had kind of a good working relationship on how they liked to see the commercial products and products in general be architected and things like that. So they came up with this list of development philosophies whenever they started working on Presto. So, big thing that they really wanted from the start was getting Presto open sourced and having a very neutral governance model. This would attract, a lot of the community and really get people involved in trialing the software, trialing, bringing in new use cases, and basically constantly making Presto better, and ultimately making it really what it is today. Another thing that Dane and Martine and really actually all three of them really harp on, but particularly here Dane say this a lot, is you need to just have it work out of the box. It needs to just be something that you can do the really simple things in a simple way, and then you can do hard things, but it's just maybe not quite as simple. So like the part that it just works, you need to just be able to set something up, and then all of a sudden you can run it. They used this commercial platform called Netezza that was really kind of an inspiration for this. Obviously, fast interactive and analytics. I mean, you have a human in the loop. They're sitting there waiting for that query to come back. You need to have it to be fast. Correct results. This was actually not always the case for Hive in many cases, because it was, it was very susceptible to, for instance, I mean, obviously programmer bugs, but then you also have like different instances of Hive in the wild that handled things in different ways. And so sometimes you would just kind of mix and match these different installations. So you could be on some older version of Hive, but then have a newer version of some other piece that kind of goes into it. And then it would actually end up creating like bad results. So, Trino and Presto and Trino was really aimed to like get rid of a lot of this stuff. And then finally, as I kind of mentioned before, we're very standards based, ANSI SQL, JDBC, and any other kind of standard that we can follow throughout the process is super important. So they created that, and it was going pretty well. Their initial setup was, basically finding all the different data stores that needed to get queried in Facebook, and then and basically the very first part, it was really difficult because they Facebook has a ridiculously huge software engineering team, so they can actually maintain all their own versions of the open source type of technology. So they have a Facebook version of Hive, a Facebook version of Cassandra, a Facebook version of Postgres, Facebook version of MySQL, like anything that you can imagine in the earlier days of Presto, they had a Facebook version of it. And so when they wanted to make this open source and kind of get other teams buy-in, they started to pull in these, new, basically a high open source version of Hive code, and then kind of Facebook source version of Hive code. And they realized really quickly that this was going to get intermingled and kind of jumbled into a lot of the core Presto stuff, and it was going to make the code very ugly. So earlier on, something really interesting happened is they decided to make this SPI layer. And this is kind of what I had discussed before, where we were talking about going out to connectors and getting the metadata and things like that. So having this actual like overlap of all these different versions of the same thing made them think about this. And this has actually now become one of the core use cases of Presto and Trino. So it's really just interesting how this was not an initial design decision for Presto or Trino, but it ended up being like probably outside of the main one, which was we need to replace the Hive runtime engine. Now it's, hey, we need to replace the Hive runtime engine, and while we're at it, it'd be really cool if we could just plug in all these other databases and make them work and run joins across these databases. And so that ends up being the use case that we're talking about today, where we can actually run federated join over Mongo and Pinot now. So this was all awesome and great. But with any story, there has to be a climactic part where it gets your heart racing and makes you really interested in the drama, right? So open source drama happens a lot of times whenever projects get super popular. Started out at this simple OSS open source software project to improve analytics. As it grew in popularity and importance to Facebook, though, there is some growing pressure on particularly Martin and David to give over the rights of full control and basically automatic committer rights to Facebook. So this had been fought for apparently like a year or two while they, I guess, from 2016 and 2018, and then one day they basically came in. Executive decision had been made to basically act on this to basically do this thing where Facebook has full control over PrestoDB. And just I think about a week or two later, all Martin, Dane, and David had quit Facebook, and they went off to fork what was initially known as PrestoSQL. The hope was that as Facebook kind of incorporated PrestoDB, it would disappear, and that would be that. They would just continue under the auspices of PrestoSQL. But that didn't happen. PrestoDB was revived because as it becoming more and more in popularity and the name was very well known, there were other companies that had incentive to basically make this a competitive project and try to kind of try to sell something out of what was existing with Presto. So they basically created a Presto Foundation, and this Presto Foundation was then donated to the Linux Foundation. And now Linux Foundation then enforced the Presto trademark in 2020 to force us to rename PrestoSQL to Trino. And that is short for the space particles called neutrinos. So there was a good and a bad side to all of that, particularly the trademark being enforced, which was, having two active, semi-active communities, our PrestoSQL community being very active, and then the PrestoDB community starting to be revived. It got really confusing for developers. And so I think this was actually a good forcing function for us to rename to Trino. And now that Trino is essentially the project where the co-founders are living under now, and it's like it makes it very clear that there is this difference. But however, we are still working with a lot of people have heard about Presto, but maybe not heard about Trino. So that is again one of the reasons why I'd like to let you guys know about that history and why I went into such depth. This isn't the first time something like this has happened too. You may, for those of you that are familiar with Jenkins, you may have known that there was a predecessor called Hudson. You may not have known that. And so basically similar kind of case happened with, I mean, almost identical, Oracle being Facebook in this case, and the Hudson being Presto, Jenkins being Trino in this case. So, I mean, not the first time, probably not the last time this kind of thing is going to ever happen in an open source type project. Just kind of the nature of the beast. Now that we're moving on, like, we've now gone on to Trino. We like to call it the ludicrously fast query engine because we all enjoy Spaceballs. For those of you that don't know, it's kind of a spoof on Star Wars. And basically, they want us to go from not just light speed. We need to go to ludicrous speed. So with the rebrand, community project has been growing a lot, as well as kind of outpacing Presto, even despite this kind of new rebrand. And we're just slowly trying to get people more aware of what's going on, what happened, and essentially, I mean, let them kind of figure out for themselves what makes sense. So yeah, as reiterated before, it's a query engine, not a database. Handles these OLAP workloads and does this MPP architecture thing. And so for those that don't know MPP, it's massively parallel processing architecture that basically tries to break down at different levels. You can have kind of this different levels of parallelism. So like across worker nodes, you can have distributed workers for Trino. It will be pulling data from the data source, and based on the workers, it will take maybe a certain set of data that goes to each different worker node. So you can see, this node here on the second to the left gets these kind of 2 block data pieces. This node here gets this particular piece, and so it's kind of segmenting maybe based on a partition or based on various underpinnings of however the table is set up or however the data source is set up. And then once you actually get into a further thing, you actually get into a thread intranode type parallelism. You can actually run the same level of parallelism across different threads. So this is just a very kind of one like picturesque way to kind of showcase what one thing that MPP architecture does. There are also multiple other things that are done in the Trino engine, which is we take, for each individual query that's passed into us in the coordinator, there's actually a custom Java bytecode that's generated for each query, so that you can actually run that custom Java bytecode and ultimately save a whole bunch of extra steps at the bytecode level. So there are just a huge amount of engineering rigor that goes into what making Trino so fast. So with that, we'll move on from that. I want to cover one last little like confusing bit for people that are first coming in, and when they're using seeing some of the use cases in SQL for Trino. So there's this concept called containment hierarchy. You may be familiar with it from, like, let's say MySQL. When you're in MySQL, you have a database which contains multiple tables, and then you need to specify which database you're using by saying use this database. So you say like use test, and then you're now on the test database, and then any table you create at that point is going to make a table underneath that test database. So this is called a containment hierarchy. And in Trino, because we are connecting to multiple data stores, we need to basically have a generic containment hierarchy that will apply across the board to each of these different nomenclatures used in different data stores. So if I'm talking to MySQL and I wanted to use that test database, I'm going to say, let's say I name my MySQL catalog just MySQL. So I would say something like MySQL test foo as the table. And so that table, that's basically in Trino side how I would actually call out that particular table if I wanted to address it. Same thing in Mongo, there's a database, and instead of calling it a table, they call it a collection. So you would need to know like whatever collection you make, that's going to be equivalent to what you would call the table. So, in our particular example, we're going to have Mongo as the catalog, transport as what we would call the schema, they call database, and then flights as a table or collection. So wanted to kind of just, put that out there as kind of like, if you're really confused by this multi-dot table nomenclature, that's where it's coming from. It's more or less just kind of a namespace so that we know which particular catalog we're joining on. So here's the scenario. We're getting closer to this, to the meat and potatoes that I've been taking a long time to build up to. So we have, MongoDB data store. It's a NoSQL document store. It's really popular to just take denormalized data, throw it into your data store, and then, you just take it out the same way. You can't do joins. So, having Trino, even if you just had Mongo connected to a Trino case, you could actually then perform joins across your own Mongo tables. But we're going to make it a little more interesting. We're going to also pull in Pinot, and this is more focused on an OLAP use case, very similar to Trino, but where Trino kind of does these batch querying analytics, Pinot is more optimized to do real-time updates, as well as basically they have these very sophisticated indexes that basically make the querying typically sub-second latency, so that if you have a chart like in your supersets application, then it's not going to take forever. You're not going to be sitting there waiting for it to load for Pinot to return the results. It's going to be much faster. So, a lot of times you'll see a database, a real-time database like Pinot, kind of behind some graphs and charts or some sort of UI type visualization for your customers. And then you'll have like a Mongo being more of the kind of internal organizational data store. So, I think it's very possible that, you could actually run into a thing where you'd actually need to join data like this, data, organizational data, and then like, customer facing data. And you need to just do this ad hoc analytics to basically pull out and see, hey, like, is there some sort of, result coming from this? And here's the real scenario that I'm trying to dream up. So you're working on a fictional commercial airline flight company called Dodo Airlines. You have all this flight data that's in your organization, so that's sitting in MongoDB, and then recently, another team got access to valuable COVID-19 data. They're putting it in Pinot so that they can kind of visualize this in a little board on the website or something like that. And your team has basically been tasked to say, okay, we need to actually enable the data science team to pull these two data sets together and ultimately visualize something on Superset. So that's up to you. We want to basically see if there's like an impact, or basically how heavily correlated is, COVID cases rising or falling to the number of flights. So this was still the demo scene. That's getting ahead of ourselves. So basically what we're going to do, first, I'd like to show you, for those of you that are familiar, this is a Pinot interface. And let me preface this before we jump into this. This Pinot, Mongo, and Trino are all running on the same node sitting out in EC2. So I just wanted to make you all aware that that's the case. And it's very possible that things may crash and burn, but don't worry, I'll keep bringing them up if they do. So anyways, we have Pinot here, and we have tenants, controllers, brokers, servers. This is kind of internal stuff that you don't really need to know for Pinot, but basically there's the one that we're most caring about is the tables. So we have this table called COVID cases offline. We can go inspect and see, but there's the schema. Where's the schema? Oh yeah, table schema here. We can actually go and inspect the table schema, see if we wanted to actually like build up some sort of query. Could say something like go to the query console, pull up the tables, and then we can actually look at some of the data and inspect it here. So this might be kind of the viewpoint from the other team that got this COVID data. They're just basically taking this and saying, okay, we want to do a count, something like a select. Yeah, let's do select We'll go by 0 to 9 years. So age group, and we'll do count 0 to 9 years. Group by, we'll take out the limit. Age group. So we basically get, we can do different things like this. And this is where Pinot is kind of really strong at it, in that it can take this data. Once you've run it a couple times, or based on how you actually set up your indexes, you can make this query here, especially as the data is getting into the kind of terabyte level. You're able to make this query kind of cache some of the results, not necessarily the final results, but can even be the intermediate results to give you answers for this or other queries that you're running in conjunction with this. So this is really the kind of primary thing when you think about like Pinot or any other kind of real-time analytics dashboard type database, Pinot, Druid, or ClickHouse. These three are really specialized at kind of making your aggregations go super, super fast. On the contrary, on the other side of the house, we have Mongo. So you might be typically used to seeing. We go to let's go to all. Oh man, my Zoom thing's in the way. Well, anyways, you basically have your choice of clicking through all the different tables that are in here on your Mongo screen, and then you can basically look to see, okay, we have this flight table that's our collection, I should say, that's sitting underneath this transport database. And we got about 4.3 million documents. It's about 4.7 gig. And, you can basically do similar types of things. You can do grouping, and aggregation's actually pretty well supported in Mongo. It's pretty fast, but it's not going to have sub-second latency like you would in Pinot. So just to kind of split out the reasons why you would use one or the other, and kind of keep motivating why they should be separate data stores on their own right. So you can still do things like, so if we wanted to update the thing to, let's say, Illinois, we can find that. We were at like what, about 502. Let's see how many flights are coming from Illinois. So about 247, still pretty heavy state to that was going out for flights in 2020 in comparison to, let's say, let's see, we'll do Massachusetts since we have friends here in Boston. I think it's MA, right? MA, yeah. And there's only like 71,000 coming out of Massachusetts. So you can actually start kind of digging in and seeing like some of the basic ideas of how you would be querying individually. But now let's actually take a look at how you would be using this straight through Trino. So actually one thing I want to do first before I hop right into that, wanted to actually show you how you would set this up. So right now I'm actually running on, basically a Docker Compose setup. We won't hop into the Docker Compose specifics here because it's basically, that's more of an implementation detail, but the primary things that you need to kind of focus on when you're setting these up, and just to show you how simple this is, you inside of your Trino configuration, you're going to have this folder called Etsy. And underneath that, you're going to have a folder called catalog. And this is how you actually like do the connection to any one of your data stores. So if we wanted to, I have a catalog that's basically mongo.properties. And this is like without security. Okay. Security adds maybe at least like 5 or 6 more lines. But without security, like this is as simple as it is to basically set it up out of the box to connect to Mongo. So you just basically tell it which connector. This tells Trino, which type of connector to which plugin to use, and then this MongoDB is actually the URL. It's internal to my Docker Compose system. We'll know that that's going to the MongoDB container, and then the port, and that's it. That's literally all you need for the MongoDB one, and almost the exact same kind of setup for Pinot. You just say it's the Pinot connector and Pinot URL, and done. And so so this is like kind of that level of simplicity, like the it just works kind of thing. You set up a couple, you basically untar it if you want to just do the really basic setup, if you don't want to mess with Docker containers or anything like that. And then once you've untarred it, you basically just add these configurations, start it up, and which they have. It comes with a little bin thing that's a script that starts it up for you, and then boom, you're able to kind of play around with Trino. I also like having it set up in Docker, and in fact, I'm working right now on a repository that will be kind of like a Trino getting started thing, and can share that out on the Superset Slack once that gets a little more in progress. It's kind of under construction at the moment, but anyways, without further ado, that's the basic setup I wanted to show you, as to all you really need to actually connect, your Mongo and your Pinot data stores here. So now let me get back to this. This is dbeaver. For those of you that haven't used it, it's basically just can connect to JDBC data stores. And so, I go in, set up my connection here. I'm pointing out to the EC2 host, and I use port 8080. This consequentially is also where the web UI is hosted. So since I don't have security set up, I can use literally any username to log in. So I just use Trino, and we have one single worker, which is also happens to be the coordinator. And so it's just sitting there idly waiting for me to run some query against it. And it's also, just wanted to point out, also sitting at, I got this Zoom thing in my way, also sitting at port 8080. So all that kind of comes like out of the box. Like you don't have to. I remember somebody was on the Slack channel asking me like, how do I set up the web UI? And it's set up already. You just didn't know it. And so so same port that you use for JDBC, you use for web UI and everything like that. So that's good. We've connected that JDBC driver. Also, if you do use dbeaver, we already have the Trino driver already installed. So you can basically, when you set up a new connection, why is this not here? I need to get into a new connections. You actually already have the option to use Trino, and it already pulls the correct JDBC down for you. Okay, so let's just go ahead and run this. So this is going to be a query that we pull out the actual positive, the day that the positive specimen came back for COVID. We also pull in the flight count and then the COVID count. This is pulling from Mongo, and then basically just pulling out the year, month, and day. And then we do the same for the date. This is just pulled out in one single field from the Pinot side. And we just do a join based on the date. And so I'm gonna, well, here we'll limit it to, I think it automatically limits you, even if you don't put that. I think it just limits you to by default to 100 per scroll. We can go ahead and execute this. And while that's executing, we can actually go and see it running here. So this is the query that I just ran. We actually can see like a live plan. And this is actually what it looked like. This is the join taking place. This is it pulling from Mongo. This is it pulling from Pinot. And you can get a lot of information here just by kind of understanding, you'd have to kind of go in and we have a book, by the way, a Trino definitive guide coming out in the next couple of weeks that explain this web UI in a lot of great detail. So you can kind of understand what this query plan is spitting out. And then, if you actually end up ever needing help in debugging on like Slack, we have this little JSON tab that spits out a JSON version of this visual. And so we can actually take that in and look at it on our side and analyze it and things like that. So this becomes a really good debugging tool, just as an aside. But yeah, we can see the query that was ran, the stages that ran on it, and kind of how those performed. And again, there's a lot to kind of digest in this web UI, I'm aware, but we won't really be getting into that today. It's kind of more advanced type topics. So getting back to the query that returned, we then get a whole huge list of dates. There we go. Whole huge list of dates and the COVID count versus the flight count. And as you can kind of see, as the COVID count goes up, the flight count kind of teeter-totters around there a little bit. So I'm not going to try to pull away too much from Srini's visuals, but I think that that's pretty much what I wanted to show on this side. Srini, do you want to? I'm going to stop sharing right here and I'll let you take over.
Awesome. That's great. It's a good overview. We'll quickly end this event by showing off the same thing in Superset. And so this is kind of it's interesting because Superset can't work with Mongo directly. So this is kind of one of the hacks is you can query Mongo through Trino. So even if you just want to use it for that use case, that's pretty powerful. So this is kind of the first tab in SQL Lab. You'll see that selecting a few columns and doing a count and a group by from the Mongo table. Let's see if your instance is going to crash or not. There we go. So we got that working. This is a query doing something similar. So just to back up a second, so Mongo has this is the flight data aggregated. So Mongo only knows about that. Our Pinot instance has the COVID case data, and this is going to be a group by as well. Sometimes there we go. And then you'll see the group by day. You'll notice that this is a date time kind of column, and this is actually split out. So and this is where the magic sauce comes in for Trino is we'll actually take these and join them on the kind of formatted date time column basically, and then we'll hit run, zoom back out. And this, out of the box Explore view in Superset doesn't really support joins. So the best way by far to use Trino is in SQL Lab. And you can take, as far as Superset is concerned, this results set is a database table. So what you can do is actually launch an Explore workflow and save it as what's called a virtual data set in Superset. I've already done that, so I won't do it again. But then when I go over to Explore, whoops, I zoomed out too much. When I go over to Explore, this is transport.joint data. So this is kind of the joined table that we have here. And all of the kind of bells and whistles you expect work out of the box, time grains. You can pick the time column, you can choose different metrics and aggregate them. And basically this chart is just the flight. So this shows in 2020, we see the peak of air travel kind of corresponding to when people started getting worried about COVID, and then it dips down with COVID cases, before March. We didn't really even know what COVID was in the US, right? And yeah, and I take both those. And one of the cool things that Superset has is the ability to have multiple axes for multiple line charts. So on this axis, we got the number of flights. Sorry, this is cases. And on the right side, we got the number of flights. And so you can see right here, let me hide my Zoom window. You can see just kind of as the flights go up and peak, you see the same kind of dip and peak as well with the COVID cases. And yeah, pretty crazy. This kind of middle region, the summer of 2020 really was the craziness. And then we took all that, put it in this nice little tidy, clean dashboard. And you can go from there. So you might want to add a date filter next via the filter box that you can actually let people filter. And the interesting thing is that this chart is from one database, this chart is from another database, but this chart is joining data from both databases. So this is kind of really the power of Trino and Superset working super well in conjunction. And all I needed to do, Brian set up Trino, and I had no knowledge. I just pointed Superset there. On the Superset side, I just needed to install the SQL Alchemy Trino driver, and we were off to the races. So that's kind of the preview of kind of these tools working so well together. And I'll pass it back to Brian to wrap this up.
Cool. Thanks, Srini. Yeah, it was really cool. And I think like that's one of my favorite things too, is like, if you have all this like trajectory going right now with Superset. You know, you guys have those new charts coming in, and it's going to like be, what are they called, Apache chart, or was it
E-charts? Yeah.
Apache E-charts. Yeah. Okay. Super cool. Like, and that just, you know, it's something that goes so well hand in hand. Like, you know, like you were saying, like we kind of enable you to do queries over Mongo now, and also do these kind of join queries. And then you kind of like, it's kind of boring to just sit at a CLI like the entire time when you're just like, you know, watching this happen. And like the only thing that you can really do to some extent is like, you know, here's the results and like here's the benchmarks, you know. And so bringing in something like Superset, you know, and putting those two together, it actually just brings the reality of like what Trino is for, and really kind of drives like, oh, okay, like the endpoint to us. So it's such a good like kind of trade-off and hand-in-hand thing. So really happy that you guys had me here today. Yeah, so if you're interested to learn more about Trino, we have a huge community. Like we're almost to 4,000 in our Slack channel, and so definitely growing like there. Like if you really start jumping into Trino, whatever you're doing, whether you're just using it or whether you're contributing to the project or wanting to write blogs or kind of update documentation, whatever you feel like, kind of, or just hanging out, talking. You know, you usually get a pretty quick response. Like I'm on there a lot. You know, I kind of if you are interested in Elasticsearch, I'm on those a lot. As well as kind of like been more recently getting into the Iceberg connector. But yeah, I think there's just, you know, a lot of momentum on our community side. So definitely join the Slack channel if you want to learn more about Trino, and you can find me there. We also have this thing called Trino Community Broadcast. So let me see if I can open it in the tab without everything exploding. Cool. We have this Trino Community Broadcast. We have, in fact, the Iceberg Show with one of the founders of Iceberg, or the founder of Iceberg, Ryan Blue. He's joining us for that. We got Druid Team coming up on April 29th. So basically just roughly what we're doing here today, just talking tech and kind of doing some demos and hanging out, having some fun. So that's trino.io/broadcast. And I can also paste some, or this will be on the recording, right? So if you need to come back and see some of these be on the recording, I can also try to see if I can copy these and paste them into the Zoom before we hop off. And then other than that, we have virtual meetups that we just started. So we just split up the globe into 3 chunks and basically said Americas, EMEA, and APAC. We're going to basically have our inaugural meetup at each of these locations. So depending on what time zone you're coming from, you can join a different meetup and it will be at a good time for you. Don't worry, that way you're not like at 9 p.m. or something like that, attending one of our meetups. So this meetup is going to be Martin, Dane, and David, as well as Eric Kwong. He was the kind of 4th member of the original Presto team. They're just going to be kind of giving the state of Trino right now. And then we're just going to kind of have a hangout to kind of catch up. This is going to be my first attempt at using GatherTown. It's basically a little virtual world where we can all hang out and chat a lot easier in spatial proximities. So definitely check that out. And then if you want to contribute, we have a nice little development page up here. It talks about the contribution process, some of our development philosophies. Particularly, you're going to want to pull down a code style. If you have any questions about how to develop or within the project, you can always reach out to us on Slack. We have a big blog section, and we are always, asking for more people that want to contribute there. If you have some really cool use case how you're using Trino, definitely hit me up and let me know if you want to write about it. And vice versa. And same thing. We have also in our doc section a lot of write-ups about how to contribute to our documentation if that's something you're really into. So with that, I hope I left enough time for questions. Please give us a star on TrinoDB, Trino, and GitHub. And again, if you want to find me, I'm also on the Twitters at bitsonDataDev.
Awesome. Well, that's great. So let's kind of leave 5-10 minutes for Q&A. So if we got a first question, so please just use the Q&A tab at the bottom of Zoom. If you don't see it for whatever reason, you can also use the chat. So Vinay asks, what is the latency on the queries over MongoDB and Pinot? How real time is it?
Yeah, so like MongoDB, that one will be probably like seconds to, it could be seconds to minutes, right? Like most things outside of these sub-second latency real-time ones are going to be more focused like seconds to minutes. And the reason why they take, you know, up to that long is that it's really depending on the underlying, you know, data store, how because really all Trino's doing is it's just pulling in the data. So we are running at the speed of your underlying data source. So one question we get asked is like, should I put Trino on top of a MySQL instance and will that make it somehow faster? And the total answer is no, do not do that. Unless you're planning on like kind of extending that out and joining it with another database. If you literally just have if you literally just have like a single relational database, you know, and that's literally going to be your only use case, like putting Trino on top of that is just going to, if anything, add more latent, just like a small sub-second of latency more, because we have to query it and then it has to go through, you know, there's a small like millisecond of, or maybe even like nanosecond of planning time to just say, oh, we're just gonna, you know, push these queries down and push these aggregations down and read the data out of the query, but it's not going to make it faster. What's fast about it, what's smart about Trino is when you are pulling across multiple databases, you know, what we try to do is we try to kind of take advantage of the internal data structures on each individual data source. So for instance, if you have a relational database, they have the best index known to man that's been around forever, which is B+ trees, right? So they can quickly, you know, find ranges of data specifically on like pre-indexed data on certain fields, right? So why not try to push that down and see if MySQL or MS SQL or you know, Postgres, if any of them have like a good index that they can use to get the data up to us faster. Once it's like in our domain, then the real magic is that we can just take that data and do like a full join over, let's say, this giant fact table, which is just basically saying a huge, you know, maybe 2 terabyte up in the petabytes type table, and we're scanning over that, trying to basically limit the amount of that table we're actually scanning, and then we merge it with something like a relational database. So that's the kind of strength that you get. And the good news is that you don't have to take the data that was in that relational database and move it into Hadoop or into wherever your big table is just to run that query. You just run that ad hoc, and it just works, you know. So that's I hope that's a kind of a long answer to that, but getting back to Pinot, that's going to be sub-second. That, you know, if you're Pinot runs at sub-second, so we serve it at sub-second unless there's a join or some other calculation going on in the query engine part. But we're basically just going to do the calculation, run the query, and then, you know, we'll add a very small amount of latency on top of that, and then it would basically come back. So if you're just directly querying Pinot, you're running at the speed of Pinot. If you're doing a join, it's going to be a little longer. It's going to really just depend on your underlying architecture.
Great, cool. We got one more question, and then I think we'll call it a wrap. Xiao asks, how does Trino generally handle RPC failures internally, i.e. one of the calls to MongoDB Pinot fail?
Yeah, so I mean, we try to do our best to basically take in any kind of exception, and we do our best to kind of over time, as like, you know, let's say you get we recently just released this ClickHouse connector, and so like probably the exceptions there are not getting handled super well. So you're going to probably see some funkiness in the early days of the ClickHouse connector being in our ecosystem. But then you have other things like, let's say, you know, Mongo's been in our ecosystem for quite some time. And so we've gone through and had a lot of run-ins with strangeness and weird stuff coming out from, you know, Mongo exceptions that get returned. And we do our best to basically update those and say, okay, how should this get presented to the user? And we basically just wrap it in our own type of Presto exception and try to present it as best as we can, so that, you know, whatever message goes in there gets reported to the client. And it would also be, you know, show up in your logs, and like the full exception will show up in your logs. In your client, you'll see like the main, you know, the headline of that exception, and then it would just kind of indicate that you as a data scientist or user need to tell your architect, hey, you know, I got this really strange thing, and here's the query. You can give them the query ID at that point, you know, because if you have the access to that web UI, you can take the query ID, hand them that, and then take the exception string that you got, hand them that, and then they should be able to grep their logs and find out what's going on.
Awesome. Great. We're a little bit over time. Thanks everyone for sticking around and powering through. And thanks, Brian, for coming on and talking about Trino.
Yeah, thanks for hearing me ramble, everybody.
Awesome. Well, I hope everyone has a good rest of the day, and take it easy. Thanks, everyone.
Thanks.